In this video, I'll discuss objects with hinges using elliptical motion, and it's in my book, Ellen's Guide to Perspective, on Amazon. To divide an ellipse or cylinder into equal units, start with the circle and divide the circle into equal parts. Then find where these lines hit the circle and transfer those positions over to the ellipse. As the ellipse gets narrower, the areas near the edges, here the top and bottom of the ellipses, get closer together, whereas the spaces toward the center are more far apart. When a cylinder is divided using the same method from the circle above, you can see that the lines near the edges are closer together than the lines in the middle. Here I've divided a flat flower and a tulip by using the circle below. So the petals on the edges are narrower than the ones in the middle. In this case, I put the flower in a trapezoid, so the petals in back are nearly as wide as the ones in front, but just much shorter in this direction. The handle of this pail is elliptical, and it has to touch the two fixation points here and here, and its tip is on this elliptical pathway. And similarly here we have the two fixation points and the tip on this elliptical pathway. Ellipses define objects that turn around in hinges like books, windows, and doors. To draw the book, we can start with this cylinder, which is the basic unit, and divide the ellipses on each end to represent pages, and have them meet at the center of each ellipse. This represents the spine of the book, and then we start developing pages in that book like this. Swinging windows and doors get larger as they approach the viewer because the cylinder is wider in front than in back. These panels converge toward a vanishing point on eye level. Now, books, in contrast, don't show much diminution with depth because they're small objects close to us. To find the treads on this wheel, I've divided this circle into even parts and then transferred those positions over, and that gives us the treads on this side of the wheel. And then we can just go through the center to find the treads on the other side of the wheel. The lid of the box circles around its hinges following these two elliptical paths. When the lid is upright, these yellow lines, it lies behind the geometric center, which is the green line. To appreciate this, I turn the image around so that the red line is horizontal, and now you can see that the green line is perpendicular to it, so it represents the geometric center of the semicircle. The yellow perspective line divides the semicircle so that it has a large area in front and a smaller area in back. When drawing lids, identify the most extreme movements, which here is horizontal and vertical, forming a quarter circle, so the edges of the lid must follow this circular shape. Notice that the undersides of the lid, these orange dots, are placed so that the lid can clear the box when it moves. Here I've combined inclined planes with elliptical movements. So the planes are connected together by this black line, the hinge, and they all converge toward vanishing points on this vertical line. Their front corners are connected by this green ellipse, and their back corners are connected by this orange ellipse. This is what a DVD looks like when it's closed and when it's open, and I drew the lid in various positions. You can see that the lid needs this room here between it and the DVD so that it can clear the base when it closes. And each position lies between these two ellipses. In my next video, I'll show you an easy way to find ellipses in cylinders. And please remember to subscribe since it helps my channel.